In this video, I will explain you about power factor and wattless current. Now, power factor I already have explained that the average power will be Vrms into Irms into cos phi. So, generally an AC output would be represented by Vrms. So, in our household application, we use 220 volt power supply. That is, there 220 volt is the RMS power. Okay. Now, the one which we are measuring is IRMS value, or the rated current would be IRMS value. So, on multiplication, we will get a power, and that is apparent power. Which is equal to Vrms into IRMS. This is very important. Now, what is this? This is actual power. So, actual power, because cos phi or the power factor cannot be easily measured, and the one which we are finding with the rated RMS and rated voltage and rated current is the RMS power. So we don't know whether it is an LCR circuit unless and until we see the variation of V with respect to I. So the moment we get IRMS and Vrms, we multiply it together to get the value of power, but that is actually the apparent power. We are expecting that the power consumed by the circuit is this much, but if at all, if there is an inductor or capacitor somewhere, then that will become an LCR circuit, and the actual power would be this. Actual power is equal to apparent power into cos phi. Now I can say that cos phi is equal to actual power divided by apparent power. See, we need actual power to be maximum, right? So for that, we need to choose those elements that will give us a power factor close to 1. Now, whenever there are L inductor and capacitors connected in a circuit, that becomes an LCR circuit. So for example, our refrigerator is an LCR circuit. Okay, it is having inductor, capacitance and capacitors and resistors. Now, if its phi value phase, phi value phase is 45 degree and cos phi would be 1 by root cos 45. What is the value of cos 45? 1 by root 2. So the actual power is equal to Vrms into Irms into 1 by root 2. See, we are expecting that it is delivering a power of Vrms into Irms, but the actual value is very less than the apparent power which we have calculated, Vrms into Irms divided by root 2. So this is 0.707, 1 by root 2 is, so Vrms into Irms. So let's say Vrms is 200 and Irms is 5. So we are expecting that power delivered is equal to 1000. Okay, but what is the actual value? Actual value is 0.707 into 200 into 5. The value is 707. See, the actual power delivered is 707, but apparent power we calculated is 100,000. So this is the reason now refrigerators are rated with 5 stars, 3 stars, 2 star, which means that gives us a value of power efficiency. Now higher the power, higher the efficiency. If it is 5 star, its power factor is more towards 1, which means when with the 1000 input we will be getting the effective power as 900 or 800 or any value very close to 1000. If it is having low power factor, when we are applying 1000 at the input, we would be getting 500 or 700, which is very less from the input value. Okay, so that is the significance of cos phi. Now government has made it a mandatory that all the element, that is all the devices that is input with AC power source have to be rated with a star value. Out of 5, how much it is? 3 means power efficiency is less, 4 means comparatively more, 5 means the highest. Okay, so if all the device which we are using is rated with 5, which means that is giving higher power efficiency. With 1000 it would be doing the work of around 950. So we can save our on electricity bill. Basically we are reserving the power. Okay, so this is the wattless current. Now power factor. Now we know that phi is the angle between voltage, this is voltage in the phasor diagram, the voltage is making omega t angle, and this is phi. So this is Im sin omega t plus phi, and this is Vm sin omega t. Its y projection would be Vm sin omega t, its y projection would be this. So the total value would be Im here, and here it would be Vm. Now Im has got two components, one along this thing, that is Im cos phi, and Im has got one more component which is in this direction, that is Im sin phi. Okay, these two are perpendicular. Okay, so this component is Im cos phi, and this component is Im sin phi. Now see, Im cos phi is along Vm, and that is delivering a power of Vm into Im into cos phi. Okay, so we have to say that is wattful power, because it is delivering certain amount of work in each second. So this is wattful current. Im cos phi is wattful current, because that is delivering power, right? Now what about Im sin phi? Is it delivering any? See, along this direction there is no voltage, so Im sin phi is wattless current. So this is the meaning of wattless and wattful current. This is delivering power, this is doing a work, and this is not doing a work. So this is wattless current. Im sin phi is wattless current, and this is wattful current. Okay.